We are going to be covering the order domain elements with the Tach decoder and the order track element. The first one that we will cover is the Tach decoder. This is a simpler element, of course, than the order tracking element. Simply put, it smooths out and decodes a tach for better use in the order tracking operation. The way that it works is you take a tach input here. In my example, I have N. You set an output speed name. This is going to work similar to the math elements where it will appear then in the viewer as a virtual channel to be used. So I have named mine N tach, and you can use the parameter settings based on the parameter element that is already existing in the design. You can set your pulses per rev input, and you can also have a mistriggered tach correction in case there are errors in your tach signal. The OT, or order tracking element, has a number of different settings options. First, here we have the basic settings, which includes the tach channel, where you take a tach from one of the channels that exists in your design already. In this case, I have named it N tach to match the tach decoder element that I have already in my design. You set your average number of revs, and you can select this continuous transform button. What this will do is provide the most possible order peaks. So it's going to process all of the orders instead of specific orders, which if you leave it unselected, you can set here. So if I just wanted to process order 1, 2, and 3, it will process that way. I will note that setting continuous transform does increase the processing time marginally over setting specific orders to process. You can also set the phase lag or phase lead here, depending on how your signals are set up. In the advanced settings, we have what you would expect from a standard order tracking FFT setup here with the number of revs overlap, the pulses per rev, block size window, and scaling similar to the FFT element that we have for spectral processing. And then finally, we have specialty settings. These are specialty settings and are highly dependent on the data set being processed. Please consult the help documentation if you are confused or need any help on this for more information. And of course, we're always happy to help you out in whatever way we can when setting these elements up. Just create a ticket on our user site. This includes a variable trigger level, a trigger threshold, and a tooth correction setting. I am going to open up a example design here. This design actually doesn't need a tach decoder element as the once per rev that we have in here is already really clean, but I'm going to go ahead and process this data now. And as you can see, I've already set up a couple of plots in my viewer here. I have a couple of bodies just to demonstrate the difference in processing between the order tracking element and the FFT element. A body plot is, of course, a over-under plot with a tracking trace of magnitude and phase on the top and bottom respectively. So here you can see a much cleaner order track and phase. Phase with the FFT is not maintained. Here with the order track, you get a much better signal. As well, we have our Campbell diagram to show the continuous transform where all of the orders are accounted for in processing.